It's also called dimensional analysis. We're going to talk about this. Some of you know it as factor labels, some of you know it as dimensional analysis in the textbook. Now, in past years, prior to the pandemic, students could walk, during free periods could walk around. You can't this year because of possible contingencies of contact tracing. But in previous years, I would have a sign on my door. If I left for a few minutes to run to the restroom, I would say, or I had to go make photocopies or something. Mr. Pujara will return in about 19 microyears. Micro is 10 to the negative 6. Calculate this value using the factor label method while you wait. So it's kind of a joke because I'm having you do something while you wait, but we'll do this together right now. So if I have 19 microyears, and I want to convert that using the factor label method, first of all, every digit or every measurement is itself divided by 1. Did you know that? There's a 1 hiding below, like this. So there's a 1 right here. The reason I'm showing you that is that this is already a fraction. That's why I'm trying to emphasize that. So we want to, when you're using the factor label method, what you do is you multiply by factors that are equal to 1. So a factor that's equal to 1. So I want to put micro in the denominator. Micro in the denominator. And 1 micro is equal to 10 to the negative 6. You saw that in the data table in the textbook. You don't have to memorize that. But this is the factor label method. So when you have micro in the denominator, then what happens is micro divided by micro gives you 1. So if you multiply this out, I've just changed this. I've changed the label instead of to being microyears. Now it's in terms of years. So I've just said, well, it's 19 times 10 to the negative 6 years, or 19 millionths of a year. Is that useful to you if you're waiting around for me? No. So what you have to do in the factor label method or dimensional analysis is now I've gotten rid of the label of micro. I want to get rid of the label of what?
Years.
Years. So if I want to get rid of years, realize that this is a fraction and years is in the numerator. That's why I said it's over 1. So in the next fraction, where would I put year? Yes, Charles?
And the numerator.
Numerator is up here and denominator is down here. Where do I put years?
Denominator.
Denominator, right. So years goes in the denominator. And then what would I put in the numerator, Charles?
You would put 1.
Well, 1 year is equal to what number of days?
Oh, 365.
Yeah, you could put 365 days, or if you happen to be a fanatic about leap years, you could say, I know it's 365.25 days. And if you happen to be more of a fanatic, you might say 365.24 something, 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 something. Because this is actually estimated, because it's even further than that. And so now, let's start talking about precision, the number of significant digits here. How many significant digits is the 19? 2. So I'm going to write 2 significant digits, 2 SD. How many significant digits is this conversion here? 10 to the negative 6 is a micro.
1.
This is exact. It's not estimated at all. It has infinite precision, infinite significant digits. It's infinitely precise. Now, 1 year is 365.25 days. How many is that? 5. So this is 5 significant digits. All right.
So you can multiply those together.
Oh, yeah. So now years can be divided out. Right? Let's use a different color for that. Years divided out. So years is divided out here. Now I want to multiply by a factor that gets rid of days. I would get another person to raise your hand and volunteer, please. Yes, I have to flip this around. Kayla,
You put days in the denominator,
I put days in the denominator because you want to get rid of days.
then you can put minutes at the top if you want.
Well, do you know how to go from days to minutes automatically? Most people don't. What would you, what's
Well,
a,
today's 24 hours and
24
one.
hours.
so you go 24 hours. So let's do it in 2 steps. So one day is 24 hours. Thank you. So then what you can see is that the day unit divides out.
Mhm.
And now we have it in, if we multiply across the top, that's the number of hours. All right, and then what we do is, now, is having it in hours going to be useful?
No.
So let's get someone else to raise their hand, please. And we'll get Simon. Sorry, Simone.
Yeah.
You know, is there an E at the end?
There's no E, it's spelled Simon, but it says Simone.
Okay, I apologize, Simone.
Okay, then you could just do it times 60 minutes over over an hour.
Yeah, the reason it's 60 minutes over an hour is that you want to divide out hours. Some people flip this, and I'm trying to show you that you want to, some people just say multiply by 60, but the reason is you want to get rid of the units of hours.
I mean, you could do 24 times 60 minutes.
Right,
6 basics.
right. So now everything is going to be in minutes. And now I happen to have multiplied this out in an earlier class because yesterday for 6th period, we did this compressed a little bit. We took a little bit fewer minutes for the introduction. And so here's the calculated value. Now, I made a mistake on that first time, 365.26, but here it is. You end up with 9.99324 minutes. Now, that might be acceptable in a math class, but we're not in a math class. We're not in Kansas anymore, Toto. We're in physics. That's a Wizard of Oz reference. If you're from Kansas, I'm not disparaging you. What's your question?
No, I'm just gonna say that you could just make an estimate of it being 10 minutes.
Okay, well, you jumped ahead a little bit because I didn't get a chance to talk about how many significant digits is 24 hours in a day.
24 hours was.
It's not 2. The reason that it's not 2 is that the 4 isn't estimated. You don't say, it's between 20 and 30. Let's call it 24. It's exactly 24 hours in a day, and it's exactly 60 minutes an hour. So these are exact.
Exact meaning.
So
Another infinite.
they're infinitely precise. This is the symbol for infinite significant digits. So when you're multiplying, the rules for multiplying are keeping the least number of total significant digits. So what's the least between 2, infinity, 5, and infinity? 2. So I'm going to draw the line here and then look at, see how I round this. So how would I round this? Can someone raise their hand and tell me? So let's see, I have to turn this around because it's, so Asher,
You would round up
so I'd round up to what?
10
Okay, so if I wrote 10 minutes like this,
of 10.0.
if I wrote 10 minutes, this is 1 significant digit. If I wrote 10.0 minutes, that's 3 significant digits
It's 1.0 to the.
times 10 to the first minutes. All right, and so this is the correct answer. Now, I always get someone saying, hey, my teacher taught me something. We raise your hand, what did your teacher tell you? Tell me, raise your hand. Go ahead.
24 hours.
No, a different way of writing this. Yeah,
10 minutes.
well, how would you, that says 1 significant digit.
Oh,
How do you, did someone teach you a way to write it as 2? I always get someone who says, oh, my teacher taught us this. My teacher taught us that you write it like this. You write 10 with a dot in it. Did anybody learn that? Yeah, we always get a few. You did?
Yeah.
And other people may have learned that you do 10 minutes and then you do an underline or a squiggle. Did anybody learn that? Okay. And some people might have learned from me that I like to put a smiley face, some eyes, make this a smiley flower.
Oh, fantastic.
You know what that means? These are all made up and not useful. Because if I wrote this, you'll wonder, what is he doing? He's in a fantasy land thinking zeros should be flowers that smile at you. And the person who learned 10 with an underline wouldn't be able to communicate with the person who learned 10 with a dot. They don't know what each other's talking about. And you wouldn't know what this is at all, right? So these are all made up. Don't use these.